surface integrals. So we'll be looking at scalar fields and vector fields. Firstly, we'll see the scalar fields. So usually what we'll do is we'll define the surface into infinitesimally small surface area elements, and we'll add up all the individual contributions by integrating over the dot product of the scalar field with the volume of the scalar elements. Now we'll look at the vector elements. So we'll think about how we can get the surface integral of a vector element, and we need to look at the flux. So we'll decompose the vector field G of R into two components, the parallel components and the perpendicular components to the surface. And only the perpendicular components will contribute to the flux, as the parallel components will give us a dot product of 0. The total flux given by the surface integral is shown by the equation. And this is the vectorial surface element ds, which is n hat ds. And we can rearrange or recreate this equation to the dot product of G and the surface element with the direction. And we can integrate a surface integral into double integrals, where S represents the surface. And ds is still the small surface elements. So firstly, we need to parameterize, where we can write them in the form S and T. So R will be a function. So essentially, R is just the way we can write the surface, and we can write the surface of a region, shown by that diagram. Then we need to calculate the infinitesimally small changes in the vector. So we'll need to compute the surface elements ds and dt. So du can be written as del r by del s ds, and dv can be written as del r by del t dt. So this is given by the directions drawn on the diagram there. So when we do the cross product of these two components, it will give us the area of the parallelogram, which is the surface area element. So ds can be written as del r del s cross del r del t, and the absolute value of them ds dt, so still writing the surface elements. Or we can write ds in the vector form, because ds is going to be perpendicular to the surface, which is perpendicular to du and dv. So ds can be written as du cross dv, which you can write as del r del s cross del r del t du dv. DSTD, sorry. And these are the two ways we can write them. So that's the first one's for the scalar field and the second one's for the vector field.